I met another interesting person, Dr. Welch. He was the scientific director of the Psychiatric Institute at Columbia University. At that time, IBRO was being created and was organizing the first symposium in India. And I was given job to organize this first IBRO meeting, to teach the professor of pharmacology of India the new things about neuropsychopharmacology. In this symposium, the interaction with Welch and the interaction with Purpura brought me the opportunity to be invited to go to Columbia University. And this is how I left Brody. A big person in the coffee business, William Black, who was selling in New York chock full of nuts, had given Columbia University $15 million to build a new research building. But they had to have research on Parkinson's disease. And I was the guy that, with my experience in Brody's laboratory with catecholamine, serotonin, I could start some meaningful research in Parkinson's disease. In Brody's laboratory, the major contribution was the idea that really to understand neuronal function, you had to measure turnover rate of transmitters. And we were the first to start with the new methods of turnover rate, and I was working there with Norton Neff, and then I invited Norton Neff to come with me in Columbia, and he started my first laboratory with Norton Neff, and then came somebody from Italy, Groppetti and Spano, and then we invited Ben Weiss to come with us, and that was the group in Columbia University. And there were 3 years of many important discoveries. When I left Brody Laboratory, I left with a very clear message. Life is a dynamic equilibrium. In life, nothing stays as it is, but changes continuously. Even something that you measure, like serotonin and catecholamines, are turning over continuously. So this was always my guiding principles in creating new ideas. Dynamic equilibrium at the regulation also of enzyme, that is, induction of enzymes. When Ben came to me, I said, what do we do? I said, let's take the pineal gland and denervate it. Let's see whether there is a dynamic equilibrium in the regulation of an enzyme that transduced norepinephrine to cyclic AMP. That was, and came out that when there was more enzyme and the innervation was regulating the enzyme that was present postsynaptically in the pineal gland. Always you stand up on what other people produces. At that time, Julie was working on the pineal gland, was making on this pineal gland a very good model for the catecholamine system. And so that taking Julie method and brought this idea of the dynamic equilibrium, came about denervation supersensitivity as a regulation of the enzyme, upregulation of the enzyme. When you have this idea of regulation and you apply this to the receptor, then comes all the innovations that I brought, for instance, in the glutamate receptor, the metabotropic receptors. Really immediately came to my mind that really nicotinic receptor and muscarinic receptor were metabotropic and ionotropic receptors. So I said, why one transmitter only should have the metabotropic receptor? Norton Neff was the first one to show that GABA had a metabotropic receptor, and then was logic to show that glutamate also had a metabotropic receptor. In research, you have to have some guiding principles. That the most significant discoveries I made is to surround always myself with young people, stimulating, and that wanted to have a career, very ambitious, and I had to create always new ideas for them in order to make for them a career. Personally, I think that the major contribution I made was the mechanism of action of benzodiazepines. And that was an uphill battle, because everybody wanted that benzodiazepine had another receptor, not GABA. Sandro and I were the first one to show that was GABA. And the other one is the importance of cyclic AMP in regulating tyrosine hydroxylase, which brought the main concept that cyclic AMP was activating protein kinase A, the catalytic subunit was going to the nucleus, and now we know that there is CREB and phosphorylating CREB and regulating gene expression. This was the first contribution of the role of cyclic AMP in regulation of gene expression. These probably were the two most important discoveries in which I was directly involved in.